This ShowMe is a demonstration of the technique of completing the square used to solve quadratic equations. This first example is number 12 from a worksheet I recently gave my pre-calculus students to practice the technique. The technique begins by segregating everything that has variables in it from everything that doesn't. In this case, we're already there. The second step then is to make sure that x has a coefficient of 1, which it already does. The third step then is to complete the square. What we're trying to do is create a pattern on the left that factors into a perfect square of a linear binomial. Well, the key to this is the middle term, which will be negative 6x. What's half of negative 6? Well, negative 3. What's the square of negative 3? It's 9. We need to add 9 to both sides. Having done that, the left side of this equation is now a perfect square trinomial. That is, the first term is the square of a number, the last term is the square of a number, and the middle term is twice their product. Because those three things are happening, we have a perfect square trinomial, and we know, without really giving it much more thought, that it will factor to x minus 3 squared. On the right-hand side, we have 17. The next step then is to take the square root of each side. The square root of x minus 3 squared is just x minus 3. 17 has two square roots, a positive square root and a negative square root. Finally, add 3 to both sides, and we have both of our answers listed in a single expression, 3 plus or minus the square root of 17. This second example is number 22 from the same worksheet that I gave my pre-calculus students. The first step is to segregate things that do have x's from things that don't. So we're going to keep 2x squared plus 8x right where it is. But we're going to add 10 to both sides so that 10 is now on the right-hand side. The next step is to make sure that x squared has a coefficient of 1. So divide everything by 2. We'll have x squared plus 4x equals 5. Half of 4 is 2. 2 squared is 4. Add 4 to both sides. We know now the left side will be a square of a linear binomial. The square root of x squared is x, and the square root of 4 is 2. This sign right here will always match the sign of our factored square root, so it'll be x plus 2 that is being squared. On the right-hand side, we have 9. Take the square root of each side. We have x plus 2 equals positive or negative 3. Subtract 2 from each side to finish the problem, and x is either 3 minus 2, which is 1, or x is negative 3 minus 2, which is negative 5. Well, I hope that helps. There are plenty of examples that also involve fractions. I think I'm going to add one more problem to this ShowMe now, where there are some fractions, just to make sure that we see what that looks like. I'm pretty sure I'm going to have to explain this one in class tomorrow anyway, so I thought I'd go ahead and practice here. The first step is to segregate the things that do have x's from the things that don't. So we have 12x squared minus 29x equals negative 15. Also, x squared has to have a coefficient of 1, so we'll divide everything by 12. So we have x squared minus 29 twelfths x equals negative 15 over 12, which is negative 5 fourths. Now take half of 29 twelfths, which is 29 24ths, and square it. Well, that'll be 841 over 576. Added to both sides, of course. On the left side, we know we have a perfect square. It's going to be x minus 29 24ths, quantity squared. On the right-hand side, we have something of a mess. Negative 5/4, I have to multiply that by 144 over 144 to get a common denominator. So now we have negative 720 over 576. So the sum of negative 5/4 and 841 576 is going to be 121 over 576. Now take the square root of both sides. On the left side we have x minus 29 24ths. On the right hand side we have positive or negative 11 24ths. Well, add 29 24ths to both sides, and we have 29 24ths plus or minus 11 24ths, which would be 40 24ths or 18 24ths. So we either have, let's see, that would be 10/6 5/3, or we have 3/4. Well, that should wrap it up for completing the square. We've got a couple of examples that were requested, and this special example is just to show that there's no reason to shy away from fractions, except if, of course, you don't have all these facts at your disposal. Don't be afraid to use your calculator. Don't be afraid to ask questions when class comes around tomorrow, and hopefully that will help everyone deal with completing the square.